Is there life beyond Earth? To find out, we might look no farther than the planet next door. Mars may be our best hope for resolving the ultimate mystery of creation.
It is the one planet out there that is Earth-like enough that we can imagine that life might have taken hold on that world.
If we go to Mars, will we find that, yes, the same events that led to life on Earth happened independently on this other planet?
And if we find evidence on our very next planet, Mars, then you have to say that has to be so common across the Milky Way, across the universe, you know, that we are not alone.
Mars has more in common with our world than any place we know of in the universe. But it's still a world away. Getting an astronaut there to search for life is beyond us. So for now, we must resort to the next best thing. Robots. Mars today is a busy place. 3 satellites orbit it. 3 landers ponder its surface. They're finding a wealth of clues.
Holy smokes, I'm just blown away by this.
When that first data comes down, the sense of astonishment is indescribable.
Oh, wow.
We would never have thought of looking for organisms like this on Mars.
But they're also discovering that in its past, Mars had some dark secrets.
Life can survive in pretty harsh conditions, but there are limits.
Around 4 billion years ago, there was a cataclysmic event.
This was big. This thing went wham right into the planet.
4.5 billion years ago, 2 young planets emerged, both brimming with promise. But something went very wrong with Earth's twin. Is there life on Mars? Up next on Nova.
Major funding for Nova is provided by the following.
One of the factors impacting energy prices is growing global demand. And one way to put downward pressure on prices is to make more supply available. ExxonMobil has invented a breakthrough technology that we've just begun using here in the U.S. to access cleaner burning natural gas that's locked in very tight, hard rocks. We could produce enough gas from one U.S. source alone to heat 50 million homes for almost a decade.
And David H. Koch. And
discovering new knowledge. HHMI.
And by the Corporation for Public Broadcasting, and by contributions to your PBS station from viewers like you. Thank you.
Mars eludes us. Even as this planet surrenders its secrets, it remains stubbornly guarded about one. The question we have come in pursuit of above all others.
The geology is fascinating, the climate is interesting, atmospheric science, there are any number of things that you can study about the planet, but to me, what makes Mars special is its potential as an abode for life.
If there's life on Mars, there could be life throughout the universe.
If it happened twice, right here in our own solar system, then we would have, for the first time, a good answer to the question, is the universe full of life? The answer would be yes.
The holy grail of Mars exploration is finding some form of Martian biology, what's often called the second genesis. Did life start on Earth and Mars? Did it evolve in a totally different way than Earth life did?
Peter Smith has been involved with 7 missions to Mars. Each has only driven home how difficult it is to get there.
This is the Mars Polar Lander, Mission Control, and the Jet Propulsion Center.
1999. The Mars Polar Lander is about to touch down on the surface. Smith and his team should get word any moment. They wait.
Oh, there's nothing worse than no signal.
And wait for a signal that never comes.
I was trying to hold out a little hope that maybe it landed and the communication link hadn't quite set up yet, but I had the worst sinking feeling.
Ooh, doesn't look too good over there.
During its descent, the polar lander disappeared.
You felt like somebody very close to you in your life, somebody you loved very dearly, had died through some tragic accident.
At the time, Smith was already preparing his next mission, another lander called Mars Surveyor. But after the failure of Polar Lander, NASA canceled the mission.
It was just miserable. All fell apart. All my house of cards just collapsed.
Smith didn't give up. His plan? To take the technology from those failed missions out of mothballs and repurpose it for another lander. Every precaution would be taken to make sure this one would make it. He christens the new mission with a name apropos, Phoenix.
We're rising from the ashes, and we're going back to Mars.
0 and liftoff.
And so, Phoenix it is. Sending a mission to Mars is somewhat like hitting a golf ball across the solar system. We'll see if we got our hole in one.
Nine months later, Smith is back on track to search for signs of life on Mars.
2, 1, mark.
Mission control at NASA's Jet Propulsion Laboratory. If Phoenix lands, it'll be thanks to the engineers here today who made it happen. But no one knows better than Smith what could go wrong.
20 meters, 50 meters, just standing by for touchdown. Touchdown signal detected.
Finally, Peter Smith has arrived on Mars.
By gosh, we are going and doing it. We have a great chance of making a new discovery on Mars. It's the thrill of my life.
Now that Phoenix has landed, NASA is sharing supervision of the mission with scientists at the University of Arizona, where Smith is based. Phoenix is in the far north of Mars, so it has just 3 months before the polar sun will begin to set for the long winter. And with it will go the lander's power supply. Time is already running out. This is the 39th time we've tried to reach Mars, and only the 7th time we've actually landed there. It is a quest years in the making. The first to attempt it were the Soviets. During the 1960s, they launched 8 missions. They failed 8 times. It wasn't until the late 70s that we get our first close view of the Martian surface, with the 2 Viking landers. Each bears a $60 million box packed with 3 biology experiments that are, in their day, state-of-the-art. They're designed to test the soil for the presence of organisms. Hopes are running high. But when the pictures come in, there are no signs of life on Mars. As the experiments proceed, the news gets bleaker.
That this was devoid of life. that Mars was just a barren desert, that it may have been interesting 4 billion years ago, but today it's lacking in those ingredients that would allow life to flourish.
Those ingredients for life are common on Earth. Billions of years ago, life as we know it needed 3 things to begin. One is an energy source, like heat, from the volcanic fury of the Earth below and the sun's rays from above. 2 are organics, carbon-based molecules, not living things, but the building blocks of life. But the third is scarce in our solar system, the medium that helps the chemicals intermingle.
The most important requirement for life is liquid water. And that's the defining requirement for life in terms of our solar system. There's plenty of energy, there's plenty of carbon, there's plenty of other elements on all the planets in our solar system. What's rare is liquid water.
Not only did Viking find no life, but no water either. Mars was pronounced a wasteland.
It was really a bummer. Mars was dead, unquote. That was kind of the outcome in the newspapers. And so we had a hiatus of missions to Mars of 20 years.
Mars slipped away from the limelight. Then, in 1996, NASA scientists unveil a Martian rock, a meteorite that had landed in Antarctica, which appears to hold the fossilized traces of microscopic life. Or so they think. It turns out the formations they found could have been produced by volcanic activity. Follow the microbe has not gotten NASA far. Instead, another strategy replaces it.
Certainly, life as we understand it requires water. So NASA's explorational mantra has been follow the water. And that's a pretty reasonable first step.
In 2004, NASA is putting wheels on the ground. ×2. The Mars rovers Spirit and Opportunity have landed and are ready to roam the planet. The hunt for signs of water, present or past, is on. Opportunity is at a spot called Meridiani Planum.
Look at this one.
Look at this!
And right away, the first pictures it sends home are stunning. Previous missions had sent photos of sheer desolation. But now, not far from the lander, is bedrock, the first ever seen on Mars.
Holy smokes. I'm sorry, I'm just blown away by this.
Bedrock is a record of ancient environments and a dream come true for mission leader Steve Squires.
This is the sweetest spot I've ever seen. That outcrop in the distance is just out of this world. I can't wait to get there.
Most of the rock on Mars is volcanic lava flow. This is something else. This is an unusual Martian rock, at least compared to what we've seen everywhere else. The fact that these rocks are layered says that one possible origin for these is that they were laid down in liquid water. We do not know what's going on here, but the beauty of it is we have preserved in front of us a record that will answer that, and we have on our rover a toolkit of gizmos that will tell us that answer.
One gizmo is a camera on the end of the robotic arm. It finds a puzzle never before seen on Mars. Tiny, smooth spheres, like so many blueberries. Could they be the product of water? The pellets probably formed in the cavities of wet soil, perhaps in a salty ocean floor. If the team can find certain salts in the rock, it will clinch the ancient presence of water. The place to find those chemical clues isn't on the surface. They would have seeped underground. If only the team could look there. They can. The rovers come equipped with a drill, the rock abrasion tool, or RAT, as shown in this NASA animation. But the man in charge of the RAT is worried.
I thought that before landing we had roughly been able to approximate anything that Mars was going to throw at us. Of course, what I neglected to think about was a rock that would be spitting out blueberries. What we're afraid of happening is that we're going to dislodge one of the spherules, and that it's going to be like a pinball machine between the RAT and the surface of the rock. And this could be something that causes us some problems.
To pick a rock to test.
That spot for ratting has to be chosen now. And I mean literally in the next, well, it should be chosen in the next, hour.
They've selected a spot that's blueberry-free, hopefully.
This, I can't stand this. It's like, I wish it was over.
That's good. Contact switches tripped.
Are you ready to give a formal go for the RAT sequence, Master? Yes, I think we are.
More definitive.
We'll go to RAT. Go to RAT. I like that. Okay. You are clear to command.
On my mark, 3, 2, 1, mark.
The RAT has been engaged.
I don't care if we find chili under there. I don't care. I just want to make that thing work.
The result?
Yes, you see that hole? I heard the fall, man.
Direct from Mars, a cleanly ratted hole.
It's the most important hole we've ever dug.
Finally, they can check the rock's chemistry. A spectrometer on board is able to read each chemical as a different wavelength, breaking them down like a prism does light. The rock is as much as 40% sulfate salt, a mineral that's only produced by soil interacting with water. That clinches it. Water was once here.
That's beautiful, man. It's so different from anything we've seen before. That's great. There's an awful lot of sulfate salt in this rock, and that's very, very hard to explain away other than water having been massively involved in creating this stuff.
If you tasted this thing, you'd taste the salt. It's a very, very salt-rich rock.
It looks like what geologists call an evaporite deposit. Evaporites form when you have liquid water with lots of stuff dissolved in it, and the water evaporates away and it leaves stuff behind.
That stuff includes the blueberries. They hardened long ago when these rocks were saturated with water. And they remained after the softer surrounding rock eroded away.
So we think we're parked on what was once the shore of a salty sea on Mars. That's pretty cool.
The rovers have proven, even if they're finding no water on Mars now, it once flowed here, probably over 3.5 billion years ago. But that doesn't necessarily mean there were living things here. It would have taken more to generate life. Amid its shallow seas, could Mars have produced that energy it takes to stir up a primordial soup? In search of clues, Spirit sets off on a journey of 1.4 miles and 2 months to explore the rugged Columbia Hills. But the trek takes such a toll on the rover, it might not make it to its destination.
This is one beat-up vehicle. This thing has traveled for 3 kilometers. It's coated with dust. We got a gimpy wheel. You know, that front right wheel is hurting.
Spirit is down to 5 wheels, and there's no one to change a tire on Mars. Its rovings may be over. The team troubleshoots with their duplicate model at JPL.
If we're going backwards, and it's not a lead wheel, it's a
It takes some, but not. It still has the pressure. Anytime you drive that wheel.
We got this dead weight hanging off the front of the rover in contact with the ground. So when we drive now, we have to drive that vehicle differently. We have to drive it backwards. We always drive backwards, dragging the dead wheel as we go. And we drag the wheel. We go very slowly. It's kind of painful to watch.
But the setback turns up a surprise.
It, against all expectations, led to the most important discovery Spirit has made. As we drag the dead wheel through the soil, it digs this wonderful hundreds of meters long trench. And we looked at the soil in the trench, and it was as white as bright snow.
The white patches revealed by the Gimpy wheel is another telltale mineral, silica, the stuff of sand and glass. This soil is 90% silica. It would have taken a lot of heat to generate that concentration. Perhaps hot springs, like the ones on Earth, existed on Mars over 3.5 billion years ago.
This is a place where there was hot water and maybe steam, and it would come out of the ground. And that provides, at least locally, an environmental niche that would be suitable for life.
On our planet, in these crucibles of hydrothermal activity, the most ancient bacteria may have first emerged. Liquid water, energy. When Mars and Earth were young, they might have both had what it takes to create organisms. Roughly 3.5 billion years ago, life may have had everything going for it on Mars.
There's a real distinct parallel between early Mars and early Earth. There's a real parallel there that strengthens the case for there being life on, having been life on Mars.
But Andy Knoll is skeptical.
Let's think about the requirements of life. Almost all of life on Earth exists within a fairly narrow band of environmental conditions.
Not all water sustains life.
It's not enough just to say water was there. The real question is the properties of water.
The way the rovers found water was by detecting salt. So how salty were those seas?
It turns out that Meridiani Planum was way saltier than anything that's known to sustain life.
If water is too salty or acidic, it can be deadly. 3.5 billion years ago, the waters of Meridiani, where opportunity is, could have been up to 1,000 times saltier than Earth's oceans.
It was pretty nasty stuff. This was not nice, pure water by any stretch of the imagination. It was very acidic. It was acid, sulfuric acid, and it was very salty. It was a brine. So it would have been a very challenging place for life.
What made the waters of Mars turn to poison? A crucial clue is revealed when Opportunity ventures to its next destination. The walls of Victoria Crater offer the chance to study the geological record. The deeper, the older.
Young rocks at the top, older rocks at the bottom. You're doing a trip through time on Mars, and the deeper you go, the further back you're going. And we use those craters to provide us with access to other rocks below the surface.
The base of these cliffs could have formed thousands of years before the rocks at the top. Was Mars wet then? Sure enough, Victoria's walls are lined with distinct bands. Like the Grand Canyon, they're classic sedimentary layers, the product of era after era of water. Opportunity discovers that, moving forward in time, the salt concentration steadily increases. That means the amount of water bearing that salt was dwindling.
At Victoria, we have evidence for some water early, less water later, still less water since then. It was evaporating, and the result was it got saltier and saltier and saltier and saltier.
It appears Mars evaporated to death. But why? What could wring an entire planet dry? Earth is able to stay wet and warm because its water is held in the protection of a blanketing atmosphere. The Martian atmosphere is today less than 1% as dense as ours. Though it must have once been robust, since water did flow here. What happened to it? Chances are the sun destroyed Mars' atmosphere by relentlessly bombarding it with solar wind. Earth's atmosphere is protected from the sun by a powerful magnetic field. That's generated by a spinning molten core, creating a dynamo.
We're lucky on Earth, we wouldn't be here otherwise. The magnetic field actually shields the atmosphere and us. What it does is it manages to keep that solar wind from blowing the atmosphere away.
But then Mars is 1/10 the mass of Earth. It doesn't seem large enough to generate a strong magnetic field. In fact, does Mars even have a molten core to begin with? Answers are emerging from a new age of Martian exploration. Satellites dispatched by NASA and the European Space Agency have been circling Mars.
The orbiters, for me, are kind of the unsung heroes of Mars. The global perspective is the thing that really gives you the understanding of how the planet works.
With data collected from the satellite Mars Odyssey, scientists were able to model the longest canyon in the solar system. It stretches the length of the continental U.S. and could fit the Los Angeles city basin within the width of its walls. With satellites, they are reconstructing the volcanic history of Mars, the planet that produced the solar system's largest volcano. Olympus Mons spans an area the size of Arizona and rises to 3 times the height of Everest. Volcanoes are no longer active on Mars, but their presence means that at one time the planet did have a molten core. Still, how could such a small planet pump up enough juice to power a magnetic field? Some scientists believe that Mars got a little help from a visitor from space. A giant asteroid. 4 billion years ago, the solar system was a violent place.
There was an influx of meteors. And in fact, there are craters on Mars into which you could fit Australia.
The theory is one object got caught in Mars orbit.
There could have been a body that was circling Mars, and it's possible that asteroids circling Mars created so much heat and so much deformation inside that it actually started a dynamo.
With sheer tidal force, the asteroid may have churned the planet's molten core, powering up its magnetic field and its atmosphere in turn, at least for a time. What then went wrong?
So on Mars, we ask the question, well, where's the magnetic field?
Earth's magnetic field is one powerful cloak. But that's not what the orbiters find on Mars.
With the Mars Global Surveyor, we put a magnetometer, a very, very sensitive experiment on board. We put it into close orbit, and lo and behold, it found the trace of an ancient magnetic field on the planet.
Unlike Earth, Mars today has countless small magnetic fields pockmarking its surface. Like shrapnel left at a bomb site, they seem like the aftermath of some violent event. One that may have also left another clue at the scene. Mars is misshapen.
We could see that the southern highlands were much higher. The north is much lower, much smoother.
Mars has a clear division cutting straight through it. The north is much less weathered than the south. The reason? The leading theory is Mars suffered a massive collision. Perhaps that asteroid drew too close.
I mean, this was big. And the idea is that this thing went wham right into the planet. Pushed the atmosphere away from the planet, just literally blew the atmosphere away. The object may have changed forever, the south and the north, making the two very, very different. And it may have been the way, finally, that the dynamo changed, the way in which it was operating, and so the magnetic field went away.
In one staggering blow, Mars may have lost the driving force behind its molten core and its magnetic field. Stripped of its protective cloak, the planet was forever left exposed to a searing assault of solar wind, preventing its atmosphere from reforming. In the areas where the rovers have been traveling, it appears that over 3 billion years ago, Mars was transformed from a warm, wet place, possibly brimming with early life, to an arid, acidic corpse. But is it certain that any and all life on the planet was wiped out?
There's part of me, I must admit, that would root for the idea of Martian life. Is it impossible that life exists on Mars? No. But I think it's not the odds-on bet.
I would take up Andy on his bet. I think the chance of finding life on Mars is high, or I wouldn't be spending my time and energy searching for it.
Chris McKay holds out hope that some organisms may have held on, adapting to a harsher world. Now, to find out if there could be life on Mars, he's headed for the ends of the Earth.
We're on our way up into the far north of the Arctic. The polar regions are a prime target for searching for evidence of life.
It's summer at Axel Heiberg, but come winter, this island can get down to 40 below. McKay has come to study a remarkable feature. Here flow two springs that are up to 10 times saltier than seawater. Salt at this concentration is usually poisonous. Could microbes survive these waters? McKay has reason to think so.
On Earth, searching for life is easy. No matter where you look, just about, you find evidence of life.
To what lengths will life go? It faces challenges world over. In the driest, hottest desert, microbes thrive. In the ocean's sunless depths as well. Even in the bowels of the earth, in caves seething with toxic fumes and scalding acid. At almost every limit, life prevails. Salty as the springs of Axel Heiberg are, they harbor miniature ecosystems.
We find a dark, rich soil right above the ice, full of all sorts of bacteria. It looks kind of like the soil you find in a forest floor. It's that rich.
So if life is this resilient on Earth, how about on Mars? Could it have survived on a planet stripped of its atmosphere? Somehow, somewhere, could it have adapted to harsher conditions and found refuge? Maybe we've just been looking in all the wrong places. The sites the rovers explored were both along the Martian equator, but there's more to a planet than just two spots.
Imagine if you just went to Death Valley or you just landed on the Arctic tundra. You know, you would get incredibly different view of the Earth.
Sure, where the rovers landed could have been an acid wash, very salty, not very friendly to life, but I bet if we landed in another place, we might find something different.
It would have to be a place that somehow retained those same life-friendly ingredients. Liquid water, not too salty or acidic, an energy source, and nurturing organic molecules. Following the water calls for at least one more stop. And this time, NASA is aiming for a spot on Mars where water may still exist. We've long known the Martian ice caps in the north and south are made of carbon dioxide, dry ice. But some held out hopes water lies beneath it. In 2002, the satellite Odyssey was able to peer below the surface to tell which elements are present.
Odyssey actually discovered hydrogen in the upper 3 feet of soil.
A vast reservoir of hydrogen, marked blue here. Could that H be a sign of H2O? If there's still water on Mars, this is where to look for it. It's time for the Phoenix lander to take up the hunt. Under the leadership of Peter Smith.
The polar north on Mars potentially was once liquid water. And we don't know that for a fact. We're going there to find out.
Tucson, Arizona is now Mars Central.
This is the latest image. This is where it came down.
Unlike the rovers, this robot is not just looking for signs of a watery past. It's taking the search for life one step closer. Its goal?
To look for water and to assess habitability. That is, in the past, was the planet able to support life, and did it?
Phoenix will focus on one area and dig. It's not designed to detect life itself, but it can tell if conditions here were once right for it.
Outstanding.
The first sol, or Martian day, and already it looks like the team has landed in the right place.
This is the most ice-rich area outside of the polar cap.
The lander uses a camera on its arm to peer under itself. It discovered that the descent thrusters had by chance cleared a patch of soil away, revealing what might be ice.
This is an interesting place we've landed. If you came out here with a broom, you could sweep off that, it's only 2 inches of soil over ice. You could actually sweep off all that soil off into a corner, and you would have almost a skating rink with some interesting bumps on it.
Hey, Matt, see the color picture, what you dug up?
No, I haven't.
Unidentified white stuff in there?
What's the white stuff that... Oh, wow.
But whether it's carbon dioxide ice, or water ice, or something else, is the question.
That white stuff.
No, yeah.
Wow.
This material we think is ice. We found some very bluish ice-like material that has the science team arguing incessantly about whether it's ice or salt or some other exotic material.
That's not permafrost. That is ice.
That bluish ice-like material turns up as nuggets in a ditch Phoenix dug. The team intentionally leaves the area undisturbed and watches.
These two, we were trying to put the pictures up on the screens as fast as we could, compare them to the pictures that we'd taken a few days before, and it just took seconds of looking at the picture to say, yes, stuff has changed.
Lo and behold, the clumps disappear.
Oh, is that true?
The reason? They vaporized. That wouldn't happen to carbon dioxide ice, not at 26 below zero.
Only water is going to actually sublimate away at those temperatures. We watched it just poof go away over the course of a couple days.
For the first time, we have touched water on another planet. And yet, how does that help the chances for life on Mars? Microbes need liquid water. Is the Martian North hiding that somewhere?
Phoenix is the first Mars mission ever to actually come in contact with real H2O. It's ice, but there it is, water, frozen solid. And the question then is, was it ever liquid?
Phoenix can find out. The robotic lab has an instrument on board that can detect if the soil here has come in contact with liquid water. It's called TIGA, and it can distinguish different chemicals by heating them in a small oven. Each boils off at a different temperature.
Okay, let's do the another tool frame rotation of -0.1.
Minus 0.1 tool frame.
Working with an exact model of Phoenix, the team's been running simulations in Arizona with dirt that's dry and granular, characteristics they expect Mars dirt to have. All they need now is to get Phoenix a scoop of the real thing so TIGA can run its test.
The right stuff slid. It's the stuff on the screen.
Sample after sample is delivered. But the dirt won't sprinkle down through the screen to the TIGA oven below.
There's a full 10-minute shake right there.
Okay, so the bottom line is we didn't get any dirt.
Not full.
Martian soil is surprisingly sticky.
Well, the TIGA instrument has not been a stellar performer, unfortunately. It's had a lot of little problems. Now, are these just growth pains or learning difficulties, or is it really an instrument on the way out? This has been a very emotional ride.
And it would give us a little more data.
The best minds in space science are devoted to one thing: getting dirt past a screen.
Just sort of do a rundown of...
So far, the dirt is winning. Finally.
TIGA oven is full.
Really?
No. Yay!
It's been a long time coming, but boy, it's sweet when it's here, right?
Okay, can we be happy now?
We can be happy now.
Soon, there's more reason to be happy. TIGA's ovens turn up carbonates, chalk-like minerals that form in the presence of liquid H2O. Water, liquid water, was at this spot on Mars. But how could that be? Temperatures recorded in the Martian polar north have never gotten warmer than 13 below zero. How could the ice here have ever melted? Another satellite, the Mars Reconnaissance Orbiter, found a clue. Probing the polar cap by bouncing radio waves down like sonar, it discovered distinct layers of dust and ice, laid down through a succession of climates, colder and warmer.
How to get layers on planets? Well, you get cycles of hot and cold over the surface of the planet.
And what makes the temperature change so much? That happens over phases that last millions of years, as the globe tilts more or less toward the sun. A planet spins like a top. The Earth has a large moon that helps to stabilize it, so it rotates relatively steadily. But the two moons Mars has are both small, so it's more prone to wobbling. Over the course of millions of years, it can tilt a lot. 5 million years ago, the Martian North Pole was angled at 45 degrees.
So the amount of sunlight that it receives in a day would be twice what it's receiving now. So imagine 5 million years ago, it could have been as warm as the polar regions on Earth.
This part of Mars may have been warmer as recently as 5 million years ago, long after the planet's atmosphere got ruined. Warm enough to be wet. Did that make the North life-friendly? Not if conditions here were extremely acidic or salty, like where the rovers landed. To find out how life-friendly this area was, Phoenix will use a second lab called Mecca. It will test its sample's properties not by heating it up, but by adding water it's brought along.
It stirs it up to determine what comes out of the soil. What kind of tea does this Martian soil make?
That's what I'm trying to find out.
Step one is getting a sample into a cell. After Tiga's troubles, no one is taking that for granted.
Anything changing down here at all?
Looking at the visuals from Mars, it's hard to tell if the soil actually got delivered. The team can only hold out hopes their experiment is underway.
Just waiting. That part was agony. Every second was an hour. It was definitely the longest hour of my life.
Then...
All right, here we go. There it is.
When that first data comes down from Mars and you suddenly see these wiggles in the screen, just like you've seen in the laboratory, the sense of astonishment is indescribable just seeing it. We know for the first time the pH of Mars.
The pH, the level of how acidic the soil is.
I want a number from 0 to 12. Something that people have been speculating about for years and years and years.
Same thing. Give us a number from 0 to 12.
There's a surprise.
Come on. Basic.
It's basic.
It's basic.
It's not acidic. A reading of 8.3. The kind of soil asparagus could grow in. So far, so good for life.
Really, Mars.
Next, what's that salt content in the sample?
Beautiful. Oh, that is gorgeous. That's as pretty.
It's unexpectedly low. Another plus for life.
At the Phoenix site, we find relatively pure ice, we find neutral conditions, we find low salts, but at low levels.
We have to look at the faster. For a lot of us, it's a new view of Mars. It obviously is not super salty, it's obviously not super acidic or super basic.
Possibly mean a rise in pH.
Bacteria might enjoy this stuff, so some organisms might be able to survive if the other part of the environment was good.
But that's a big if. Just when all readings are pointing to a life-friendly environment, one comes up that's baffling.
After the initial analysis, that's where things started getting truly interesting. Kalita, take a look at this.
There's an unexpected chemical called perchlorate.
It was about the farthest thing from our imagination that we might find there.
On our planet, perchlorate is a toxic chemical manufactured for rocket fuel and fireworks. It's rare in the natural world, except in the most forbidding deserts on Earth.
This stuff, liquid perchlorate, is not a material that microbes can very easily live in. It's not a very friendly environment.
Life can survive in pretty harsh conditions, but there are limits.
What are the chances of life amid perchlorate? It's a new question for Mars scientists. Not for John Coates.
People have said that the presence of perchlorate on Mars is indicative that life couldn't be present, that this compound is too toxic. But that statement is not true.
At a lab in Berkeley, California, Coates and his team have been quietly studying a group of microbes that is about to attract some attention. These are his subjects, organisms that thrive on perchlorate, consuming it as we do the air we breathe. A trait that could come in handy on oxygen-deprived Mars. The Martians we've long sought may be like these bacteria, called Dichloromonas.
We would never have thought of looking for organisms like this on Mars. Now that we know that this compound is present on Mars, it certainly opens up that as a life form that could potentially have existed on Mars.
Could Dichloromonas or its alien counterpart have ever stood a chance on Mars? Phoenix will never know. Its experiments done, the team disperses. As the Martian polar night descends, the lander's solar power dwindles. Phoenix will soon be entombed in dry ice, never to awaken. The search for signs of Martian life will fall to the next mission. The Mars Science Lab, MSL, will be the size of a small car. It will be bristling with technology. An array of imagers, sampling tools, and labs that will make its predecessors seem quaint.
I'm very excited about MSL. In an interesting way, it's a complement to the Phoenix mission. To me, we've already followed the water. We know there's water on Mars. Check on the water. The next thing we need to do in terms of a strategy for life search is follow the organics, find organics.
We have come a long way in meeting our neighbor next door. We've gone from envisioning it as barren and moon-like to a place as diverse as it is familiar. A world that could well have harbored life. We can now imagine the day, billions of years past, when two planets took their turn round the sun, neck and neck in the race to claim life's course. We know what happened on Earth, but the other was dealt a blow. If there's proof on Mars of a life-filled past, it is still waiting to be discovered.
On NOVA's Is There Life on Mars website, check out our Q&A with a NASA astrophysicist, explore interactives and slideshows, or watch any part of this program again. Find it on pbs.org.
Next time on NOVA, the epic story of two Arctic journeys a half-century apart.
We were making our way in waters never sailed.
Two men, two different fates.
We don't know what it was that was killing them.
One unforgiving land.
This evidence is strongly suggestive of cannibalism.
May God protect us. The search for the Arctic Passage on NOVA.
Major funding for NOVA is provided by the following.
One of the factors impacting energy prices is growing global demand. And one way to put downward pressure on prices is to make more supply available. ExxonMobil has invented a breakthrough technology that we've just begun using here in the U.S. to access cleaner burning natural gas that's locked in very tight, hard rocks. We could produce enough gas from one U.S. source alone to heat 50 million homes for almost a decade.
And David H. Koch. And
discovering new knowledge. HHMI.
And by the Corporation for Public Broadcasting, and by contributions to your PBS station from viewers like you. Thank you. And David H. Koch. And
discovering new knowledge. HHMI.
And by the Corporation for Public Broadcasting, and by contributions to your PBS station from viewers like you. Thank you.
Mars eludes us. Even as this planet surrenders its secrets, it remains stubbornly guarded about one. the question we have come in pursuit of above all others.
The geology is fascinating, the climate is interesting, atmospheric science, there are any number of things that you can study about the planet, but to me, what makes Mars special is its potential as an abode for life.
If there's life on Mars, there could be life throughout the universe.
If it happened twice, right here in our own solar system, then we would have, for the first time, a good answer to the question, is the universe full of life? The answer would be yes.
The holy grail of Mars exploration.
Is there life beyond Earth? To find out, we might look no farther than the planet next door. Mars may be our best hope for resolving the ultimate mystery of creation.
It is the one planet out there that is Earth-like enough that we can imagine that life might have taken hold on that world.
If we go to Mars, will we find that, yes, the same events that led to life on Earth happened independently on this other planet?
And if we find evidence on our very next planet, Mars, then you have to say that has to be so common across the Milky Way, across the universe, you know, that we are not alone.
Mars has more in common with our world than any place we know of in the universe. But it's still a world away. Getting an astronaut there to search for life is beyond us. So for now, we must resort to the next best thing. Robots. Mars today is a busy place. 3 satellites orbit it. 3 landers ponder its surface. They're finding a wealth of clues.
Is finding some form of Martian biology, what's often called the second genesis. Did life start on Earth and Mars? Did it evolve in a totally different way than Earth life did?
Peter Smith has been involved with 7 missions to Mars. Each has only driven home how difficult it is to get there. 1999. The Mars Polar Lander is about to touch down on the surface. Smith and his team should get word any moment. They wait.
Oh, there's nothing worse than no signal.
And wait. For a signal that never comes.
I was trying to hold out a little hope that maybe it landed and the communication link hadn't quite set up yet, but I had the worst sinking feeling.
Ooh, doesn't look too good over there.
During its descent, the Polar Lander disappeared.
You felt like somebody very close to you in your life, somebody you loved very dearly, had died through some tragic accident.
At the time, Smith was already preparing his next mission, another lander called Mars Surveyor. But after the failure of Polar Lander, NASA canceled the mission.
Oh, it was just miserable. All fell apart. All my house of cards just collapsed.
Smith didn't give up. His plan? To take the technology from those failed missions out of mothballs and repurpose it for another lander. Every precaution would be taken to make sure this one would make it. He christens the new mission with a name apropos, Phoenix.
We are rising from the ashes, and we're going back to Mars.
0 and lift off.
And so, Phoenix it is. Sending a mission to Mars is somewhat like hitting a golf ball across the solar system. We'll see if we got our hole in one.
Nine months later, Smith is back on track to search for signs of life on Mars.
2, 1, mark.
mission control at NASA's Jet Propulsion Laboratory. If Phoenix lands, it'll be thanks to the engineers here today who made it happen. But no one knows better than Smith what could go wrong.
20 meters, 50 meters, just standing by for touchdown. Touchdown signal detected.
Finally,
Folks, I'm just blown away by this.
When that first data comes down, the sense of astonishment is indescribable.
Oh, wow. We would never have thought of looking for organisms like this on Mars.
but they're also discovering that in its past, Mars had some dark secrets.
Life can survive in pretty harsh conditions, but there are limits.
Around 4 billion years ago, there was a cataclysmic event.
And this was big. This thing went wham right into the planet.
4.5 billion years ago, two young planets emerged, both brimming with promise. But something went very wrong with Earth's twin. Is there life on Mars? Up next on Nova.
Major funding for Nova is provided by the following.
One of the factors impacting energy prices is growing global demand. And one way to put downward pressure on prices is to make more supply available. ExxonMobil has invented a breakthrough technology that we've just begun using here in the U.S. to access cleaner burning natural gas that's locked in very tight, hard rocks. We could produce enough gas from one U.S. source alone to heat 50 million homes for almost a decade.